Good day, viewers. You are welcome. How to find the value of x and y, given that x and y are members of natural number, where we have x to the power of 3 minus y to the power of 3 equals 61. So to solve this, we are going to recall that here we have x cube minus y cube, which is known as difference of 2 cube, and where we turn this one to x to the power of 3 minus y to the power of 3, this is given as x minus y open bracket x squared plus xy plus y squared. This is known as the identity for x cube minus y cube. So suppose we let it to 61, as we have x minus y open bracket x squared plus xy plus y squared. This equals 61. And since we say x and y are members of natural number, we need to look for the factors of 61. Suppose we multiply 61 by 1, and we also say 1 multiplied by 61. So these are the only two factors of 61. But which one are we going to pair this? Are we going to pair the two? No, because we should know that since we have x minus y equals to this, that is, we are going to let x minus y equals to any of these, but which one are we going to let x minus y equals to? So we are going to note that this x minus y, anytime we have it, is always less than x squared plus xy plus y squared. No matter how the value of x and y we get, so we are going to make sure that x minus y is less than this. Therefore, we are not going for the first one, we are going for the second one. As when we let this one equals to this, we let this one equals to 61. So this is cancelled, and we only go for this according to this explanation. So therefore, x minus y, this is equals 1. Call this one equation 1. And also x squared plus xy plus y squared, this equals 61, and we call this one equation 2. So when we recall from equation 1, which is x minus y, and if I make x the subject of the formula, we have x equals 1 plus y, and we call this one equation 3. So let's try to substitute equation 3 into equation 2. That is, anywhere we have x, we replace it with 1 plus y. So here we have 1 plus y raised to the power of 2 plus 1 plus y close bracket y plus y squared equals 61. So when we expand 1 plus y squared, we have it as 1 plus 2y plus y squared, plus again, when we expand this, we have it as y plus y squared, then plus this y squared, everything equals 61. So the addition of y squared plus y squared plus y squared, that gives us 3y squared. Then 2y plus y, that gives us 3y. And plus 1, let's take 61 here, we have minus 61, everything equals 0. So when we have this expression, so by subtracting this, we have this as 3y squared plus 3y. So 1 minus 61 is minus 60, everything equals 0. And suppose we divide both sides by 3, and we have this cancelled, and this here is 20. We are left with y squared plus y minus 20 equals 0. And here is a quadratic equation. So we can factorize this and we get the result, because the factor of this is y squared plus 5y minus 4y. So 5 minus 4 is 1. And 5 times minus 4, that is minus 20. So we have this as minus 20 equals 0. And next we have the combination of this is y squared plus 5y, this in bracket, minus open bracket 4y plus 20 equals 0. So y is common. We take it out and we are left with y plus 5 minus, by taking 4 out, we are left with y plus 5 equals 0. So combining y and minus 4, we have the result as y minus 4, open bracket, y plus 5. Everything equals 0. And with what we have here, we have the value of y equals 4, comma, y equals minus 5. And since x and y are members of natural number, and minus 5 is not an element of natural number, so we reject this and we only go for y equals 4. So when we now record from equation 3, which is x equals 1 plus y, and where we have y equals 4, then we conclude that the value of x here equals 5, because y equals 4 and 1 plus 4 equals 5. So this is x and this is y. So if we try to check for this, where we have x raised to power 3 minus y raised to power 3, so we will see that we have x to the power of 3 minus y to the power of 3. If x is our 5, that is 5 to the power 3 minus, and y is 4, which is 4 to the power of 3. So 5 to the power of 3, that gives us 125, and 4 to the power of 3 is 64. And when we subtract this, we get 61, which shows that the values we got really satisfy this problem. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share, and subscribe to this channel for more math content. See you in the next class. Never stop learning. Bye bye.